Again, osmotic pressure, however, we'll be using a little bit differently this time. In this case, we'll try and calculate the molar mass using the osmotic pressure changes. Okay, and so here's our question. Our solution has 0.833 grams of polymer of an unknown structure in 170 milliliters of organic solution and was found to have an osmotic pressure of 5.20 millimeters of mercury at 25 degrees Celsius. What's the molar mass of the polymer? So that's the question. And since this is osmotic pressure, we're going to go ahead and use our formula, which is pi is equal to mRT. So we don't use I here, we don't use the Van 't Hoff factor because we're not told that it is an ionic substance. So we're going to assume that it's going to be 1. All right, so since we're using this formula, we have R, which is the gas constant, which means that we need to convert everything into SI units. Okay, so which means that 5.20 millimeters of Hg should be converted to atmosphere, which is then divided by 760 millimeters of Hg, and then 25 plus 273 should give us the Kelvin. That's 298 Kelvin, and the pressure is going to be 0.00684 atmosphere. Okay, what are we calculating for over here? We are calculating for the molarity, okay, because that's what we don't know. We know the osmotic pressure, which is given to us over here. We know R, of course, and we know the temperature, okay? So then molarity is osmotic pressure divided by RT, and that is 0.00684 atmosphere. I always advise you to write your units all the time. That way you know you're on the right track or not. So 0.0821 liters atmosphere over mole Kelvin, and then temperature here 298 Kelvin. So then you go ahead and cancel out your units over there. So you're left with liters mole over mole, which if you inverse, that would be moles over liters. Okay, and so this is equal to 0.0002797 moles over liters. So you can also go with exponents if you want to, 2.979 if you want. That's okay, it doesn't matter. And then molarity is equal to moles over liters. Okay, and so we just calculated the molarity. Moles we don't know. Okay, liters is given to us, which is 170.0 milliliters divided by 1000. Okay, and so the moles then is equal to molarity times liters. So molarity is 0.0002797 moles over liters times the liters is 0.170 liters. Okay, so once you do that calculation, you should come up with 4.76 times 10 to the negative 5 moles. Yes, I give up. I'm going to start using the exponent. All right, so this is the moles of our polymer. So again, remember, molecular weight is grams per mole. So if you're trying to calculate the molecular weight of something, you already have the grams given here, which is 0.8330 grams. Divide that by 4.76 times 10 to the power of negative 5 moles. So once you get the answer for this one, it will be 1.75 times 10 to the power of 4 grams per mole. Now remember, it said it's a polymer. Polymers are usually pretty big and heavy, so yeah, this is fine. Okay, that it is such a heavyweight molecule. So this is how you would calculate the molar mass of any substance, okay, using osmotic pressure. Usually if you keep your units correct and your formulas correct, your answer should come out to be correct.